Hi, I'm JD, and what we're going to be doing today is a hypothesis test for proportion. Let me read the problem first. It has been found that 48.7% of U.S. households have investments. A random sample of 400 heads of households indicated that 223 have investments of some sorts. At the alpha equaling 0.02, does this suggest that there is a difference from what was found before? So if you would, pause the video and see if you can try to do this one on your own. Alright, step number one, right up here. Step number one is you want to list out the hypotheses, your null, and your alternative. Your null doesn't have equals in it. Your null has equals in it. Your alternative never has equals in it. So look at your conclusion, or what you're trying to prove. Does this suggest that there is a difference? Well, when it says that, is there a difference, it doesn't matter if it's increase or decrease. Just that it's one or the other, right? Could be either or. So the proportion is not equal to what was found before is the 48.7%. Let's convert that to decimal. So it would be 0.487. And this would be your claim. Now your null is going to be the opposite. So it's going to be P equals the proportion of the population equals 0.487. Step number two is you want to find your critical values. Now, since it's not equal to, it's going to be a two-tailed test. So it's going to be left and right, and then this equals half of the alpha. So this is 0.01, and then this is 0.01 as well. So you need to find these critical values. To do that, you need your chart for your z-scores. Now I need to find something that's close to this. Notice the picture on the bottom has this. So I want to look for something that's close to 0.99, right? Because this right here is 0.01, and so the leftovers would be 0.99. And you want something close to that, which looks like 2.33 is close to that. So 2.33. Notice what this is saying. This is the ones and the tens place in this column, and on top it's the hundreds place. So basically what you do is you see where the two line up, right? Find your value first, which is 0.9901, and look to see where those line up. The row is 2.3 and the column is 0.03. Okay, so that's how you come up with 2.33. Now on this side, since this is a bell-shaped curve and it's normal distribution, so it's symmetrical. So this would be 0, and then the other side would be negative 2.33. Right, next you want to calculate your test statistic. Now here's the formula. Z equals P hat minus P over the square root of PQ over N. Now what's P? What's P hat? Well, P hat is the proportion of your, I'm going to put all the variables and stuff up here. P hat is the proportion of the sample, which would be 223 over 400. Now I'm going to round this to 3 decimal places. So it would be 223 divided by 400, which is 0.558. On my calculator, I got 0.5575. Now, P is the proportion of success for what we're looking at, which would be the 48.7%. So that would be 0.487. Q is 1 minus that. It's the proportion of failure. So that would be 1 minus 0.487, which is 0.513. And then my N would be the sample size, which here is 400. Alright, so I'm just going to plug all those in. So 0.558 minus 0.487 over the square root of P times Q, 0.487 times 0.513 over 400. And before we move on, just to let you know that in order to use z-scores for a binomial distribution, you have to make sure that n times p and n times q are both greater than 5. And here it should be obvious that they are, right? Because I have a sample of 400. And you have such and such. So anyways, you want to plug this all into your calculator. And again, I'm going to do 2 decimal places just like right here. I'm going to put the whole numerator in parentheses. So parentheses 0.558 minus 0.487, close parentheses, divided by, and it's the square root. Now the square root acts like a grouping symbol, so it just groups all those together. So square roots, and so I don't need parentheses around the denominator. That's what I meant. So 0.487 times 0.513 divided by 400, close for the square root, and I get 2.84. 2.84 falls right there. Falls in the rejection region. So step number 4 is I'm going to reject the null hypothesis. Step number 5, I'm rejecting the null hypothesis. That means I am accepting the claim. So there is enough evidence to support the claim that there is a difference. And that's it.